I'm Clive Roberts, Professor of Railway Systems here at the University of Birmingham, Head of School of Engineering and the lead for UCRIN, the UK Rail Research and Innovation Network. UCRIN has been developed so that universities are able to engage with industry of various sizes. So we have our founding partners who are mainly large OEM type organisations, but all businesses in the rail industry have mechanisms to engage with UCRIN by approaching the individual universities or the centres of excellence, being in digital systems, infrastructure, rolling stock or testing, or coming to some of our events, our engagement activities where we reach out to industry. The UCRIN Centre of Excellence in Digital Systems is focused on how we can take original concept research at low TRLs all the way through to demonstration and implementation. Particularly at that lower TRL work, we're working in 4 main areas: railway operations and signalling, looking at new concepts for signalling and how we understand railway systems, work in data integration and cybersecurity, also work on how we can use sensors better for condition monitoring, but also for innovation and implementation of automation, but also how we can introduce that innovation into the rail industry through better systems engineering, business model development.
One of the important features of UCRIN is being able to take the fundamental university research and actually create innovation from that. So to develop new innovative ways of working, new methods, new technologies that can be used in the industry. So it's really exciting to be showing you around our building today. We've just moved in the last few weeks and we're beginning to commission some of the testing kit and the research equipment and move in the researchers, and we're really excited about the future when we'll begin, as coronavirus passes, to be able to engage with industry, work alongside some of our industrial partners within the building.
My name's Dr. Chris Ward. I'm head of the Control Systems Group here at Loughborough University, and I also lead the UCRIN activity also at the university. At Loughborough University, we are in 2 of the centres of excellence, that for rolling stock and also for infrastructure. And that really reflects the broad range of activities we do here in terms of our expertise of dynamic modelling, of condition monitoring, control systems, and really how we apply those to real-world industrial problems. So we do research across what I would call the 3 bands of technology readiness level for universities. We do things down at the very fundamental level, which is new engineering science. We then take that through to things in the laboratory environment, like we are now, to further that understanding, and then we get things out into the field as well. An example of a very low technology readiness level is our world-leading position on vehicle mechatronics, where we're taking traditional railway vehicles and rethinking how they steer through track switches or current infrastructure. Another example of a project that's stepped through the TRL levels is something called Repoint, which is about reimagining track switches to get rid of some of the fundamental redundancy issues that are present in those systems. So that started as a thought exercise around network constraint, where capacity is limited by failures in track switches. That was then moved on to a laboratory demonstrator, which is just across the other side of the room here, which enabled us to engage with key stakeholders in the industry and work on those key issues. And then finally, what's behind me here is the actuators that we had in a full-scale demonstrator just down the road at Quorn.
We've recently completed a piece of work in collaboration with GWR and Hitachi, looking at decarbonising the new bi-mode trains on the run from London Paddington down to Plymouth. Here at Loughborough we used our skills in fundamental modelling to build a model of those trains, collected some data from a run from London to Plymouth on the train, and used that to understand the carbon emissions of those trains, and then to work out strategies for the control and operation of the trains so that we can reduce their carbon emissions. Concluded that we could reduce the carbon emissions by about 19% over a London to Plymouth journey.
So welcome to the University of Huddersfield. My name is Simon lwnicki. I'm the Director of the Institute of Railway Research here at Huddersfield. I'm proud to show you around our new facilities here. This is the UCRIN lab. We have our new pantograph test research facility and our new motion platform for passengers and driver environment. Thomas is our motion platform. It's a multi-purpose motion platform funded through the Ukraine grant that we received, and we can use it for testing the environment and for things that affect the environment for passengers. We can seat passengers in different configurations, and then we can subject the capsule with the passengers inside to vibrations which correspond to what the suspension and the track quality would have applied to the vehicle. When we first received the Ukraine funding and we were deciding exactly what facilities to set up, we talked to all the partners within Ukraine. In particular, we talked to the vehicle manufacturers. And one of the key things that came out was that we needed a pantograph test facility for various reasons, to test innovative pantographs, to test their effectiveness, to try out different innovative arrangements in the design of the pantograph, and to try to reduce the incidences of faults, of high forces on the overhead wire, and failures from that type of fault. We're currently working with a number of pantograph manufacturers to try and improve the designs of pantographs so that they more effectively provide a consistent and a reliable performance in terms of engaging with the wire and drawing down the traction current. Harold is our roller rig. It's a full-size roller rig, the only full-size roller rig in the UK. And with this roller rig, we can bring in railway vehicles. We tend to work with bogies, so we can bring in innovative bogies. Bogies, for example, we're testing at the moment a bogie with a carbon fibre frame. So we're looking at making the bogie frame, instead of making it out of steel, we're making it out of recycled carbon fibre. We can cut the mass of the bogie frame by 50% by doing that. And Harold will then allow us to test the bogie or the railway vehicle running at high speed in a controlled environment with all of the forces and all of the motions that it would see when it was running along the track with irregularities, track with curves and so on.
Ukraine isn't just academic and industrial institutions, it also includes Network Rail, who lead the Centre of Excellence in Testing. This tie-up is unique in allowing members access to rapid testing and proving facilities for rolling stock, plant and infrastructure innovations. There are rail innovation development centres at Melton and Tuxford, providing unique facilities, as well as Acton and Stratford and Long Marston.
I'm John Porrell, Technical Director of Pandrol's Fastening Systems product line. As a founding member of the UK RRIN, Pandrol has benefited from direct access to some of the leaders in the field of noise and vibration based at Southampton University's ISVR. They have assisted in the measurement of the acoustic stiffness of Pandrol's HSB system, along with the track decay rates from measurements taken at the High Speed College in Doncaster. The HSB system is at the centre of Pandrol's robotic pre-assembly system for high-speed slab. Pandrol's HSB fastening system being tested to the European standard for high speed, successfully completing 15 million cycles at 70 mm of vertical adjustment and 5 million at 140 mm.
Ukraine is a network of UK universities and industry with a mission to make rail an affordable transport mode of choice which has low carbon impacts and something that everybody wants to use, but also to try to promote and export UK rail expertise around the world. So a couple of major projects in those areas. The first one is looking at why embankments and cuttings continue to fail many years after they should have come into equilibrium. Is it because of increased environmental stressors? Is it because of the effects of a century of cycling between winter and summer? Or is it that we're using them more intensely? And that's being investigated by a consortium of universities in a project known as Achilles. The second project is about decarbonisation of electrification and thereby making it more affordable. And that covers everything from the pile foundations that support the overhead line masts through to looking at how the pantograph on the vehicle interacts with the infrastructure, through to clever engineering, like electrical engineering, which can reduce the costs of doing the infrastructure, the electrification of the infrastructure in the first place. So at Southampton, we've got this large structures testing hall. We have a smaller laboratory which tests sort of materials at a smaller scale. We have a state-of-the-art geomechanics laboratory and a geotechnical centrifuge. And we've also got the high voltage laboratory, which is particularly useful in looking at railway electrification. So we're open to anybody to use the facilities. Obviously we need to find a way of funding that, but we can help people apply for funding. There are various grants and various schemes that can happen, but in principle, usage is open to all.
The universities are really helping us with our research and development programme, and they're helping us with a real deep understanding of issues in a number of areas, and it's got real practical significance to us. It's supporting our research and development programme, and we're really proud about that. We didn't have a big research programme in recent years, but we've stepped it up. We're investing a lot of money in research, and the universities are really helping us with a lot of clever stuff. But the deep understanding that the universities can bring can help us find good long-term solutions and save a lot of money in the long run. So I think UCRIN has brought the universities together in a very coordinated way that really helps us. It provides us with an organisation that we can talk to and build a relationship with. Working with many, many different universities individually would be hard for an organisation like Network Rail. But the way that the universities have come together in a coordinated and organised fashion, playing to the strengths of each individual institution, so that different universities specialise in different areas. But for us, UCRIN is very much a one-stop shop. That organisation and structure has been really, really helpful for Network Rail.